Hi everyone, myself Satin Jaiswal and welcome to my channel Coding Card. So in our previous session we learned how to solve grid problem where we were moving in the four directions. So this was the problem to count the total number of island in which we were moving in only four direction, up, down, left and right. So we will solve the same problem in which we will moving in diagonal direction as well. So I will be explaining you in details here. So this was our previous example. So I explained you here. So in previous example, we moved only up, down, left and right, vertical and horizontal movement. Now, we will be solving today the same problem in which we will add the diagonal movement as well. So this was the four direction in which we moved up, down, left and right. So when we were moving up and standing on any cell with value I comma j, so for moving upward, the I value was being decreased and the J value was constant. So when we were moving one unit upward, so we were decreasing I by -1 and J we were simply adding 0 as a constant. For going down, I value was being increased by 1. So we were adding 1 and J value was 0. For going left, the I value was constant 0 and J value was being decreased by -1 for moving one unit left. For going right, for the cell on which we are standing, we were adding 0, 1. The I value was constant and J value was being increased by 1 unit when we were moving in rightward direction. So let me explain you here. Let me draw one grid. Then I will explain you what value we need to add when we are going to move one unit diagonally, either top left, top right, or bottom left or bottom right. So let me explain you here. All right. So this is my J value and this is my I value. Let me write the I comma J value. So our grid is ready. Now suppose we are standing here. We are standing here means we are standing at 2 comma 1. This is my I comma J value. Okay. So from here we can move in upward direction, right, downward direction, left, right. This was the four direction which we already discussed in the last session. So we can move up, down, left and right. Now we can also move top left. From here we are going to consider diagonal movement from here. So top left means top left, diagonal, top left, top right, top right, okay, bottom left, bottom left means in this direction, and bottom right which will be in this direction. So for example, if we are standing here, this is my shell, so this is my upward movement, downward, left, right, all four direction. Now this is my top left, top right, bottom left, bottom right. This is my total 8 direction, right? 4 horizontal and vertical and 4 diagonal. Top left, top right, bottom left and bottom right. I hope this is clear. Now we are standing at 2 comma 1. We are standing at 2 comma 1. So for going one unit upward direction, we are at I comma j. Now to move upward 1 unit, what we need to add here, which we already discussed. If you are going up here, see here in the cell, if we are going up here 1 unit here, so you can see here the I value is being decreased by -1, right? And j value is constant, which is 1. Here also 1, 2 comma 1 and 1 comma 1 means we will be adding -1 comma 0. This I have already explained. Now if you are going down, what we need to add? For going down, if you are at I comma j, so I value is being increased by 1 and j value is constant, right? Now for going left, see here, for going left, I value is constant, 2 comma 0, 2 comma 1 means if you are at I comma j, then you need to add 0. I value is constant, and if you are going left, then you can see here j value is being decreased. Here it is 2 comma 1. If you are going 1 unit left, then it is becoming 2 comma 0 means j value is being decreased by -1. This I have already explained. If you are going rightward direction and if you are at I comma j, if you are going rightward direction means I value will be constant 0 and j value will be added 1. J value will be added 1, right? Means if you are going in rightward direction, you can see here currently you are at 2 comma 1, you are going rightward direction 2 comma 2 means I value is fixed 2 and j value is being increased by 1, so you added this one. So this was already discussed in the previous session. You can see here the same value here. Now we are going to work on what will happen if we are going in top left direction. So see here, you are at 2 comma 1. Currently you are at 2 comma 1, which is my I comma j value. And if you are going top left and you are going in top left direction means you are going here. Let me change the color. And you are going here, top left direction here. See the value. You were currently having the value. You are currently having value 2 comma 1 and the value changed to 1 comma 0, right? Means both the value I comma j got decreased by 1 since we were moving 1 unit in top left. So if you are standing at I comma j, then what you need to add here? -1 comma -1, because I and j both were decreased by 1 unit. You can see here. See here. Hope this is clear. If this is clear, then what will the value for top right when you are going in top right direction? So if you are standing at I comma j, so what you need to add here if you are going in top right direction? So see here, you are at this cell now. When you move 1 unit top right, so you are at 2 comma 1 and you moved top right, top right. So the value changed. You can see here 1 comma 2 means the I value got decreased. See here, the I value got decreased by -1 and j value got increased by 1 unit. See here, from 2 comma 1 it changed. This I value got decreased by 1 unit and j value got increased by 1 unit. So I have added -1 comma 1. Hope this is clear. Now next is you have to move. Next is we are going to move bottom left. So bottom left is this direction, this cell, right? If you are standing here, so currently I am at 2 comma 1 and I am going bottom left. So bottom left, this value changed to 3 comma 0, right? So if you are going bottom left and currently at cell I comma j, then what the value we need to add here? See, I value got changed to 3, means I value got increased by 1 unit. So I value will be added by 1 unit and j value got decreased by, see here, j value got decreased by 1 unit. From 1 it got 0. So -1. Now going bottom right here in this cell means you are currently here and going in this cell. I have taken this 2 comma 1 as a standing point. That's it. That is my reference point. Now going bottom right, you were standing at 2 comma 1 going bottom right. So the value changed to 3 comma 2. So I also increased by 1 unit and j also increased by 1 unit. So if you are standing at I comma j, so for going bottom right, both the value got increased by 1 unit, right? So I hope this is clear. If this is clear, then this problem is clear. So just spend 2 minutes how the value are getting changed, then we will solve this problem. So to formulate the logic, it's very simple. Stay at any unit cell. Suppose this is my I comma j, right? Now move in all the 4 direction, vertically and horizontally, up and down, then diagonally in all the 4 direction, and one by one simply calculate the updated I and j value what needs to be added here, so that we can formulate the logic like this one, right? Very simple. Now let us solve this problem. So this was our previous logic where I explained you this movement up, down, left and right, and later on we took one direction list and updated this logic. So what we will do, we'll do the same thing. So let us paste here. So this is our code in which we executed this one for the very first time to know how we are moving in all the 4 direction stepwise, and later on we added in the direction list and just minimize the code in this manner. So for now let us comment this one and let us uncomment this one. Okay, so this is for moving in 4 direction. This is for moving in 4 direction, and now let us write the code for moving in 4 diagonal direction. This was vertical and horizontal direction and 4 diagonal direction. Let us write the logic here. So let's copy one and then paste here. So what we need to add here for going, what we need to add here, check for moving top left. So For going top left, what we have written here, -1 and -1. We need to add, right? Now we have to, let me zoom this one. Now we have to check the condition for top left. So for top left, for going in top left direction, both R and row and column value are being decreased by 1 unit. So let us first check the boundary condition. So this is correct. R minus 1 should be greater than or equal to 0, and at the same time C minus 1 should be greater than equal to 0. So this is my boundary condition check, and after that we need to check grid of R minus 1 and C minus 1. If that is land, if that cell is land, then what we have to do, we have to perform a DFS, right? So R minus 1 and C minus 1, this will be my updated row and column value. Hope this is clear. Now going top right, let us copy this one and paste here for top right. So when we are moving top right, so in top right, which value was being decreased and increased? So for moving top right, you can see here, I value was being decreased by 1 unit and J value was being increased by 1 unit. Means I value should be decreased. So you can see here, row minus 1. This is correct. This is the boundary condition. R minus 1 should be greater than equal to 0, and column value, since column is being increased by 1 unit, so I need to add here C plus 1. If it is increasing, then I need to check it should be less than the total column value, right? For moving the boundary condition, top boundary condition, and grid of R minus 1 and C plus 1. If that cell is land, then we have to do the DFS traversal by passing the updated row and column value. Make sense? Let's see this boundary condition. It's like you are here. This boundary condition is like you are in a cell, you are going in this direction, and suppose this is the last cell. So here my I value was being this is my I comma j. So I value was being decreased, right? So that should be greater than equal to 0. For I, my condition should be I should be greater than equal to 0, because this I value was decreased, right? And j value was being increased. You can see here. So what I did, when you are moving in this direction, so I value should be always, this is my boundary condition, right? This is my boundary. So I need to check this boundary condition. So I value should be greater than in equal to 0, and j should be, this is my I and this is my j, right? So j should be less than the total column, right? Since j value is increasing, j plus 1. If you are moving 1 unit up, it is becoming j plus 1. So up at a point, we will be reach here where, suppose this is 0, 3, for example. Suppose this value is 0, 3, and you reached at a point where my I value is 0, right? And j value is suppose this value is 0, 3, okay, and you reached here, current I comma j value is 0, 3. Now you reached here. Now further you cannot decrease -1 and add 1 in this I comma j, right? Because this will be -1 and this will become 4, which will just go out of the boundary, right? That's why we have written here the condition row should be, since row is being decreased by 1 unit, so it should be always greater than 0, and column is being increased by 1 unit, so it should be less than the exact column value which we have already calculated here, right? So this is calls. So what we will do here, we will check here calls. Make sense? Similarly, what we will do, we will check for bottom left and bottom right. Bottom left. So for bottom left, if you see here, the I value was being increased by 1 and J value was being decreased by 1. So R value was being increased by 1. If it is being increased by 1, then we are increasing the row value. So it should be less than, the final boundary condition should be less than the total number of rows, but it is being increasing 1 by 1, right? And column is being decreased by 1 unit, so column minus 1, it should be greater than equal to 0, right? And row plus 1, column minus 1, that cell should be land. If it is land, then we have to call the DFS row plus 1 and column minus 1, right? I hope this is clear. When you are going bottom left, so row value is being increased. If it is increased, then we have to check the boundary condition, so that R plus 1 should be less than the total number of rows, and column value is being decreased, then it should be always greater than 0, okay? And the cell on which we are landing by 1 unit, it should be land. If it is land, then we have to call the DFS traversal. Now let us go towards bottom right. So in bottom right, both R and C, means both row and column were increasing. So columns should be also checked with the boundary condition. It should be less than total number of columns. Simply plus 1. Cause in bottom right, both the value were increasing. So it will reach here. It will reach this corner. So for this corner, if you are going in this direction, so we should be inside the boundary only. So my I and J should be less than rows and less than columns, right? That's why R plus 1 should be less than rows and C plus 1 should be less than columns. And also R plus 1 and C plus 1, grid of R plus 1 and C plus 1. If that cell is, and also when we are moving 1 unit towards bottom right, if that cell is land, means that is of our use, we have to again do the DFS traversal. So let us take one example. So let us take this matrix as example. Now let me paste here. Now see how many total island are here if we are moving in all the 8 directions. So this is one island, right? But if you are standing here, you can move in diagonal, right? So if you are moving in diagonal, you can cover all this cell If you are here, you can move forward direction, means in the right direction. If you are going right direction, again you can move here upward direction, capturing all. If you are here, you can move in this direction also. So here we have a single one island. If you see here like this, because all the total land are being traversed. This is being traversed vertically, upward and downward. Here we are traversing in diagonal direction. Here we are going towards left and right. Again here up and down. Again here diagonally. So for this problem, it should return a 1. See here, it returned 1. Let us take another example. I have 3 4 samples. So for this one, we got how much? For this one, we got answer as 1. Let us take this example. Now, let me paste here. Now see here. For this one, for this grid, you can see how many island are here. So for this one, this land, we have only 1. Because if we are moving upward, no land, diagonal, right, no land. So this is a single 1. 1 is captured. Now for this one, you can see it has 1 here. Because if you move diagonally, this will be covered. So this is 1. For this one, okay, if you are here, you can go in this direction. So this is also captured here, right? And this is single unit, because here all the other direction are having water. For this one, the diagonal is here, which is water. So total how many? 3, right? Total 3. So if we execute this one, you can see total 3. So this is working fine. Let us take one more example. So for this cell, let us copy this one. Now see here for this cell. So this is one single island. This is one single island. Because for this direction water, diagonal water, upward direction water. Now for this one, we have these two are diagonally connected, right? And here we have 2. So total 4. So for this one, it will return 4. So for this one, it will return 4. You can see here, it is returning 4. 4. So I hope this is clear. So this was the logic to traverse in 4 diagonal direction: top left, top right, bottom left, and bottom right. Now what we will do again, let us comment this one. Let's comment this one. Let's comment this one and take one direction list. Because going forward, we will be using this logic only. Now this was for moving up, down, left, and right. So here only we will add for moving top left. So in moving top left, both row and column were being decreased by 1 unit. Now next, let us add for going top right. So phi value was being decreased and j value was being increased by 1. Now going bottom left. So for going bottom left, I value was being increased and j value was being decreased. And for going bottom right, both the value were being increased by 1 unit. So this is our direction list in which we have added all the 8 direction, and one by one we are iterating in the direction. So for example, for the very first time, we are going in upward direction. So if we are currently at R comma C, then we have to add the new dr and dc. So this will give us the updated new row and new column. Then we have to check the boundary condition. Once the boundary condition is checked, then you have to check whether that grid, whether that cell from that grid is land or not. If it is land, then go for the DFS with this updated new row and new column. After that, again it will iterate in the next direction, downward direction. Now again for this downward direction, it will update its new row and new column in the same way as I have explained you here. We are performing this logic only. We are performing this logic. We are performing this logic. We are updating the current row and column value and then applying our DFS traversal. So we are done. Let us run this code for this last matrix. You can see here the output is 4. If we comment this one, and execute, then output should be 3. It will take this matrix as an input. Now let us comment this one. So this will be the input matrix. So for this one, output should be 1. So it is working fine. So going forward, we will apply this logic where we will take the direction list. We will take a direction list and we will simply iterate in the direction list and update the new row and column, and we will go for the DFS traversal. And if there is any additional logic to count the largest island or smallest, then we'll apply accordingly. So that I will explain you in the next session. I hope you understood this problem where we were traversing in total 8 direction and how the value of R and how the value of I and J are being changed. So I have explained here in details and I have implemented the same in the code. So the logic is very simple. As you have seen here, we are simply calling the DFS recursively by passing the new row and column value. So in the next session, we will try to solve that hacker rank problem. This one, DFS connected cell in a grid. So this is very simple problem. Although they have written difficulty as a hard, but this is a very simple problem. I will explain you. So once you have understood this logic, this movement logic, then that is a very simple problem. We have to simply add a small logic over there while calling the DFS. So if you have learned something new, please do give a thumbs up and subscribe to my channel Coding Cart and stay tuned for the next video. Thanks for watching.